Hello, this is Jeff Dunham with PEA Sensors. Today's webinar is going to be the LZR FLATSCAN 3D swing door safety sensor system. And if you notice on the upper right of this screen, that icon is our icon indicating this is a laser-based technology. It's a laser sensor system often referred to as time of flight, since laser technology using a laser diode, we are emitting laser and then receiving laser, and we're just counting, measuring the time, how long it takes to emit and receive. By knowing that, that's how we determine distance or the range. And that's an advantage to knowing the distance because then you can manipulate the detection fields for your applications. Agenda, it will be the introduction, detection fields, applications, virtual push button, wiring, teach-in, configuration and specs, and some tips and tricks. Pedestrian sensing solutions, sensing technology that maximizes the convenience and safety of people moving in, out, and through a building. What's in the box? Here's a box that I have in my office of a system for a single door. We have two sensors, two cap kits. The cap kits are for the device, the plastic device that fits in the bottom of the sensor that will either receive the harness wiring or not. And then we have the primary cable with that's the loop cable and the cap for that. The primary cable, which is shown at the bottom in gray, and then the secondary cable or the pass-through cable is also shown there. And then user's guide. In this example, this is a beta unit, not yet released, but as you can see on the water mark on the instruction manual. But note that this kit is for a single door, but it's not necessary to use it as a kit or a set. You can install one sensor on one side of the door and walk away from it if you want. You could also mix and match. The previous version of this, the LZR-FLATSCAN, you could use an LZR-FLATSCAN on one side of the door and use the LZR-FLATSCAN 3D on the other side of the door. The harnesses and cables, they're all the same. They're all interchangeable. You can mix and match whatever you need for your application. Additionally, you could use this product as well as the standard flat scan in a fixed or static location. It doesn't necessarily have to be installed on a door. In fact, you can install it on a sliding door, on the side of a sliding door, and it could scan the whole threshold area of a door. You can install it horizontally. You could lay it flat on your desk and it could emit a horizontal field. Here are some pictures of what the sensor looks like. And just note on the upper right of this image, the spacer, that's a spacer that's used for the sensor to mount to. You would mount that spacer to the door and then the sensor to the spacer. Sometimes the spacer is needed because certain door hardware, painting hardware, may interfere with the first laser curtain. Next, showing these are two sensors that are exactly the same. They are nothing until you apply the power or the cable for the power coming in. The one on the left, by virtue of being powered, will be termed primary. The one on the right is being termed the secondary because it's being fed power from the primary sensor using that pass-through cable. And then on the right side there, that lower right of that sensor, the cap, that cap is what's used to basically terminate the end of the sensor housing because there's nothing coming out there. And then also on both sensors, kind of on the upper left area, you see the red dot. That is the setup or teach-in button to launch a teach-in for the sensor. And then there is a bank of 4 dip switches. and we'll explain those shortly. I guess is a good time to explain the dip switches. The first dip switch determines if the sensor is going to be used as a stop or stall sensor. That would be the default setting. So dip switch 1 is up, indicates it's going to be a stop or stall on the swing side of the door, and it will display a red LED. If you want to use the sensor or install it on the approach side or the non-swing side for reactivation or activation, then you flip that dip switch down and it becomes the green LED for the reactivation. Here's a really short animation on 3D field depth. Here we've got a pair of doors and we're showcasing the approach or reactivation side, each sensor emitting 4 laser curtains, and that is the default setting. It's emitting 4, giving you complete coverage of the swing area and more, where we're showing on the left side the whole front area. This is the pinch zone area, which is an even higher resolution area in this area. This is the area that will detect a 3/4 inch object at 13 feet, which is the maximum detection field size for this sensor. If we take that down to 7 feet or half of that 13 feet, 6.5 feet, we're looking to detect a 3/8 inch object. Very high resolution. It will detect small objects. The intent is to detect a finger. Another image of an elderly lady walking through with a walker, showing 4 detection fields for each sensor. Here's something new, perhaps you may not have seen before. So he's showing the FLATSCAN 3D with 4 detection fields. And this person doesn't want to touch anything with their hands. We have the ability to program 2 virtual push buttons. There is a special programming mode. You can configure a spot within the second curtain, C2, wherever you want it to be. If you position your, in this case, the foot or a hand or arm in that spot and hold it there, it would cause detection. So you can cause the door to activate without touching anything. And in this case, they've applied a sticker on the wall to position your foot in this area, and it would cause detection. Here is an overhead view or overhead example of a pair of swing doors showing the sensors configured by curtains on the swing side of the door. The default setting is curtain C1 through C4, and then we can configure it down from there. You could use curtain C1 through C3 or C1 through C2, or just one single curtain, which would be C1, be very tight to the door. Here's the same picture we previously saw, but showing as a point of emphasis the detection points at 28 inches above the finished floor. That's our requirement for ANSI. It shall detect a minimum high 28-inch high person. And then the second example down below is showing 4 inches above the finished floor, or approximately 84 inches or 7 feet from the sensor, are the detection points of curtain C1 through C4. And as we see, the distance down from 7 feet away is decent, where we've got it. The first one is C1, about 3.5 inches from the face of the door, and then C4 being about 44 inches from the face of the door. But if we're doing our ANSI check and we're looking to detect a 28-inch high person, this is where we're at. This is the example that we're going to see, about 29-inch depth. And then that would be also repeated on this other door, but not shown for this example. Detection zone animation. Let's watch this. There's the pinch zone, and then the leading edge zone. That leading edge zone will expand as the door is opening and closing, and then it will retract back as the door comes close, because we know the door position, the angle of the door opening. Here are the two possible virtual push button locations as an example. Detection zone outputs. So just like the flat scan, we have the same ability to have our relay 1, relay 2 output. So relay 1 is the stop or stall, as we see by the red, and then the green is the reopen activation output, and that's tied into the approach side and the pinch zone area. It will reopen the door. Wiring, pretty straightforward. Red and black is the power supply or power for the sensor. And note on the left of the red and black, we show 12 to 24 volts DC, and that is a range. It could be 14, 16, 18 volts DC. But what it cannot be is a 24 volt AC transformer coupled with a bridge rectifier. That will not work. That will place the power supply out of tolerance for the sensor, and you're going to get an amber error flash on the sensor. So you cannot use a 24 volt AC transformer with a rectifier. I think you could use a 16 or 20 volt AC transformer with the bridge rectifier, but not a 24 volt. And then the stop or stall output, that's output on the blue and the brown wires, and then the reopening output, the green and the white wires. And then if using the virtual push button, that's utilizing the gray wires, and then test or monitoring are the purple wires. The sensing field opening angle, this sensor on the left would be as if it's mounted on the upper left part of the door. The red is the area that the opening angle, the sensor is emitting to cover that angle. It's a radius, a 13-foot radius that equates to, if you install it on about an 8-foot wide door, you would get complete door coverage. But anything wider than 8 foot, that radius is going to come into effect. And then important enough, on the right side, showing a pair of scissors trimming the door loop. That's pretty critical on the installation part. Because of the high resolution of the laser sensor, it can easily detect that door loop. Therefore, it's necessary to trim it up to the shortest possible length so that it doesn't cause inadvertent or unwanted detection of the sensor. Dip switches, we spoke about dip switch 1. Here are the other 3 dip switches. We have environment for background and the pinch zone. If you want to use the pinch zone or not, you can turn it on or off based on that. And then whenever you change a dip switch, regardless, dip switch 1, 2, 3, or 4, the sensor is going to flash orange, and it needs confirmation. You press and hold this setup button for about 3 seconds, and then that will confirm the changes, and then it will also tell you how many sensors are connected. In this case, it's either going to, by a green LED, it's going to either be 1 or 2. You'll have one as a single sensor, or you'll have the pass-through cable connecting the second sensor. LZR-FLATSCAN 3D teach-in. It's actually much harder to draw this and explain it than to show you, which we do have an animation we'll show you shortly. Let's walk through this. We go to the sensor, that red setup button. You momentarily press the setup button, and the sensor will blink red, green, red, green, red, green. Wait for it to flash green, and then you step into the field, reach out as if you're going to shake hands and swipe up or down, and that will define the width of the zone. Then the sensor will cause the door to activate, to open, and then the sensor will switch from flashing green to red, and then the red will learn the door closing. Once it's done, the sensor light will go out and you're done. Let's go to the animation. Press the teach in button momentarily. Red, green, red, green. When it goes green, I'm going to make my hand swipe. It's going to trigger the door to go open. And it's going to go to red while it's closing. Pretty quick. Let's go back and let's watch that one more time. Tips and tricks. I think we got 4 of them here. Have a remote, have a BEA remote control handy. You may need it, you may not. If you need to change the sensor output from normally open to normally closed, you will need the remote. Also, if you want to change the detection zone width, the detection zone height, the pinch zone, or the uncovered zone, you can do that with their handheld remote control, or you can adjust the background and masking. Also, cardboard. Why do I need cardboard? Sometimes you'll need it to create a faux or false wall. If you have a guide rail that the sensor can look through that, or if you have floor drains or certain pedimats that have holes in the floor, the sensor can look through the floor, and that causes issues. If it looks through the floor initially during the setup, while it's trying to look at the floor, that'll cause issues. Also, if you have an adjacent glass wall or an adjacent door, you don't want the sensor to inadvertently react, reopen, or stall. What happens is if you have a glass wall during the teach-in process, the sensor will look through the wall, and at some point, someone will be on the other side of that wall causing detection. Likewise, if you have an adjacent door, a bank of doors, and if that other door opens, this sensor could detect that other door at some point, causing unwanted detection. Learn process. Prior to doing a teach-in, obviously you want to have your door operator, your speed, your forces, your time delays. You want to have those configured before you do the sensor teach-in to basically alleviate the option, the third part on the cardboard with the adjacent glass and wall. You want to put the sensor into service mode by pressing and holding the teach-in button for more than 3 seconds. That will render the sensor output inoperable, and then you can launch the teach-in. The teach-in will do a proper teach-in successfully, and then when the teach-in is done, the service mode will expire and it'll cease operating. The teach-in renders the outputs off or inoperable for 15 minutes, but it's canceled once the teach-in is finished. And then the final is just a reminder about the power supply. Do not use a 24-volt AC transformer with a rectifier. BEA also manufactures and has a power supply, which is really a small enough one that fits inside your operator housing. It's a filter regulated DC power supply, and it looks just like a computer laptop power supply. So it's fairly small and straightforward. LZR-FLATSCAN 3D configuration. Here we're showing some examples of how you can use the remote control shown on the right of the screen, changing the output from the output logic from normally open to normally closed. And then you can adjust 3 additional things, the detection zones or the dimensions of the detection zones by the inch. We can change the width of the pinch zone, the width of the door zone, and the height of all zones by the inch. Maximum width and height is 157 inches. That's 13 feet. You can adjust that by the inch. And then some additional adjustments. You could adjust, we call the uncovered zone. The uncovered zone is the inactive area from the floor or ground to the bottom of the sensing detection field. By default, if you do nothing, that is 4 inches. From the ground upward, 4 inches, you will not be able to detect anything. The sensing zone essentially is hovering about 4 inches above the ground as the door is moving. And then the background or masking settings, you can adjust that with the remote. And then the detection field depth, that's curtains C1 through C4. As we said earlier, 4 curtains are enabled by default. If you want to change that, you can. C1, 2, 3, or 4. Specifications, this is a laser scanner, time of flight. It's a presence or motion. It can detect motion as well. The maximum detection range is 13 feet diagonally, which is a radius. And then the angles of each curtain C1 through C4. We kind of showed you that on that slide that showed the detection at a given distance and measured at a given height. Minimum object size, 3/4 of an inch at 13 feet. Power supply, 12 to 24 volts DC. And it says be operated by the self-compatible power supply. That's just a better quality, low voltage power supply. Dimensions, about 5 3/4 wide, 3.5 tall, and about 2 inches thick. Operating temperature -13 to 140 degrees. Troubleshooting, all of this is included in the instruction manual. Depending on the LED function, it may be a bad teach-in. It could be unwanted detections due to environment or external conditions. The sensor is protected by a password, tells you how to troubleshoot all of those. And then more information here if you don't have an LED, whether you've got power or some other issue. Troubleshooting continued. This is after you've got power. The orange or amber LED will blink a certain rate from 1 blink every 3 seconds up to 6 blinks every 3 seconds. That will be 2 blinks per second. Each of these flash rates indicate something. Probably the most common may be the 2 amber blinks every 3 seconds. That is your power supply is out of limit. If the power supply is wrong, it'll tell you that. Also, if you have a communication error, you'll get 3 blinks every 3 seconds, 1 blink per second. And a teach-in error indicated by 5 blinks every 3 seconds. And that is it for customer service sales. If you need warranty, pricing, shipping, availability, you can contact at the phone number 800-523-2462. Also, that's the direct email, orders-us@beasensors.com. If you need support, field support, technical support, wiring, troubleshooting, installation, ANSI standards, you can contact BEA Tech Support at the same number, 800-523-2462, or they have an email alias for that entire department, info-us@beasensors.com. And then finally, your contact information, depending where you're at in the United States or what province in Canada, we're not sure. Your particular salesperson is listed here.